Hey, so I'm gonna try taking you guys through some of, I guess, week 5 and week 6's recitation works, and perhaps some of the homework, but probably not. Anyway, so this is really when the Matlab course starts getting, I guess, more difficult than it was before. Previously, you pretty much just did a bunch of basics, manipulated some matrices, I guess, and did operations on that. But with this week, you kind of start doing more complicated things. So we're going to take a look at that. Like user-defined functions. So this problem here, pretty much the idea here is to make a user-defined function, in this case, myfunct, and send input to that, and it's going to basically do things. And we're going to do our typical plotting by first giving the data to the user-defined function, and then it's going to do, I guess, the grunt work. So, in this case, our user-defined function is essentially going to be this equation here, but we're going to send the data through a separate M file, and it's pretty much going to plot it that way. If you really want to, you could, I guess, read through this prompt and pause the video, read through the prompt if you want. You probably already have it. It usually doesn't change problems that much. So I'm just going to take it as granted. So initially he gives us some values here, A, B, and C, and we also have this initial X region from 0 to 4. So I'm just going to go ahead and declare those. And also, so for some reason I see a lot of people using this command window a lot. You really want to get into the habit of putting everything in a script. Like even when you're doing like simple computational work, a lot of people use the command window, but you really want to avoid that, because at least with the script you have a way of re-inputting your work without, I guess, entering it again. I know you could just, you know, scroll up through all this stuff with your arrow keys, but really it's more advantageous to just have everything written out so you could just run it over and over again when you get the errors. For similar reasons, I always put this statement at the top of the code so that typically you'll have variables stored over here, and you'll be using some variable names over and over again, like X or A or B, and there's something called global variables, and typically you'll be doing multiple projects per recitation. If you use X for, I guess, 2 different projects, those variables could, I guess, carry over between projects, and what you want to do is you want to prevent that from happening. So every time you make a new cell, I guess I'll make one here for this exercise, which is exercise 1, you really want to clear the variables and pretty much have a blank slate. Same thing with the command line, so that's what this is doing. So everything that appears in this command window is going to be erased, and everything that's over here set as variable will be reset. So, and now I forget what the values we were supposed to use were. Well, A is 0.5, B is 2, and looks like C is 3, and X is going to be a range of values between 0 and 4. Okay, and that's what we'll start with. Okay, and the next thing we need to do is make that user-defined function. So, of course we haven't created it yet, but eventually we're going to send all 4 of these parameters as inputs to this function. So what we need to do now is we need to create the function. So at this point, it deserves to, I guess, what I'm trying to say is you need to be careful about what you name your files. So I'm doing this here. I'll call this 5 and 6 practice, and I guess I'll get rid of this my function I already made previously, and we'll start with a new one. Okay, so I'm making a file, and this is going to be your function file. So your function file needs to have the same name as what you're calling it in your, I main file or your recitation work file. So if you're calling the function myfunct, this new m file needs to be named myfunct, right? Then after that, all you need to do is pretty much put the bulk of your contents in there. Actually, I want to show you how Sophocles did it. See if I have those. Probably do. No. Okay, that's unfortunate. Okay. So, in that case, I believe the syntax is function myfunct, or now function y equals myfunct x abc, and eventually later on we're going to end it. And okay, so what's going on here? This is called a declaration, a function declaration. So the name here needs to match the name of your file, your m file, in this case myfunct. This is the name of the function, and it's how you call the function from other areas in your code. So this is calling this m file with these parameters, and it's giving these actual values to this function here. Now what do we actually want to do with this? We wanted to set this function to the actual equation that we were given, which was over here. So I'm going to do exactly that. So we have x minus a times x, and of course here we're multiplying this expression by this expression, but what is x? X is a vector, so we need to be careful and use that dot multiplier because we want the corresponding elements of the vectors to be multiplied. We don't want to actually do matrix multiplication. So we do that by using the dot operator. And what are we adding it to? Adding it to sine c times x. Okay, so what is this piece over here? Y is what we're going to call the output. So at the end of the day, what is this function going to return? It's going to return y, and what y is a numerical function that is given by this. And that should be fine. So typically you save function files. If you try running function files, you're going to get an error. That's totally fine. That's pretty much expected. But over here, you'll see that if we run in the main file, we won't get an error. We'll actually get the output of y. Okay? So what do we want to do now that we have y? Well, apparently we want to do a variety of things, and one of those is fplot. So we want to fplot it, we want to find the mins, and I suppose we want to find the zeros. Okay, well I'll find the mins and the maxes, yeah. Since you guys should be getting pretty used to finding that stuff, that should be pretty old hat. So first let's fplot what we have between 0 and 4, because that's the same x range that we're using. Okay, so this is an error I expected. Typically, fplot needs a function handle. We didn't actually use a function handle here. So now we should be fine. And there's our function right there. So now what we need to do is we need to find the minimums and the maximums of this. And you've probably done a little bit of that, or a lot of that, in the plotting, I guess, week. Probably week 2 or week 3, I don't remember. So the way you typically do that is you use this function called fminbnd. And I guess if you haven't used that before, it's always a good idea to look at the documentation for this kind of stuff. So basically fminbnd, you give it a function, and typically you give it a value that's your guess, yeah, between these two values. So that would be like, okay, for this, the min is probably between 1.5 and 2. So I would do fminbnd, the function, which is y. What did I say? 1.5 and 2. Okay. Make it 1.5 and 2. Just like that. And what it would return is the actual x value, that's the minimum. So that's at 1.66, right around here. And I'm going to want to store that value. I'll call that the first minimum. Because if we look over here, it looks like there's a second minimum between 3.5 and 4. So all I'm going to do is simply copy paste that code and get the second minimum that way. So if we want the actual function values at that point, that's going to be pretty simple because we have the numerical function. So if we want this value along the y-axis, all we need to do is input the x and we will get the y. So since we want to start doing a lot of that, I'm actually going to get rid of this f plot. And we're going to start, I guess, putting everything on. So if you're using a regular plot, you actually need to input the values that you want. So for instance, we have our x values, then our y values, and we want that to be a blue line, so we're going to do that. And that should bring up this plot here. If you don't believe me and thought that was just the f plot from before, I'll run it again, that's what you get. And then we want to add the minimum which is found, which is that. The y value, what it's found at, is simply the substituted value there. We'll make these red, so same kind of deal here, and that should give us 2 red points. Okay, small spelling error, no big deal. I guess I made that spelling error twice. And those are our 2 minimums there. Okay, so what's the procedure for finding the maximum values? Well, that's also a trick you should have learned by now. Basically what you want to do is you want to turn the graph upside down and then find the minimum that way. So basically if you turn the graph upside down, this point will come down to here and your max will actually be a min. Let's see if there's a good way for me to actually demonstrate that. Yeah, so if we put it upside down, we now have 2 more mins to find. So that's exactly what we're going to do. We're just going to use the fminbnd yet again to find our maximums. So I'll call this one fmax1 and fmax2. And over here we're simply going to flip the graph upside down, but these bounds we need to alter. So hold on a sec, I've got to comment this out. So we know our first max is going to be probably between 0.5 and 1, and our second max between 2.5 and 3. So let's add that information in. And let's see if we get an error message. Okay, that's another pretty common error that I was honestly expecting. So we gave it y, and the problem with that is y is a function of x here, so we should need to actually put it in, I believe, with a function handle, but I could be misremembering this. Ooh, yeah, that's problematic. Yeah, so another thing you need to get pretty used to doing is troubleshooting in Matlab. That's a pretty common problem you'll be dealing with. Is just remembering how to figure things out, I guess. I don't want to take forever, so I'm actually gonna look at what I tried before. Okay, yes, so same idea, I just gotta put the function handle before, and that makes sense because the type in this first parameter to be a function handle. So if you put the -1 times this, you're still going to get -1 times a function handle, which is an ill-defined sort of operation. So this instead should, and of course I still need to put the x's there in this case. So now that runs. Okay, so sorry for the big confusion there. Here we don't need to do that because this is what we define the function as, so it goes to y and it finds out that y is this, which is what we want. So if we wanted the flipped upside down version, we could either multiply by 1 here, but that ruins our user-defined function, or we can redefine the function here using the -1 and this function handle. So that's a bit nuanced, but think about it for a bit and it'll make sense, especially if you think about the data types. So now we should have those points we actually need to graph them now. So, well, actually, I guess copy pasting might actually slow me down there. So I'm just going to put the points in here. Let's make them green this time, I guess. And max 2, y affects max 2, and green again. Did I make the same spelling mistakes as last time? Yeah. Okay, so here we have the green dots up here. Okay, so again, let me just go over what we did so far. So we had to make a user-defined function to graph this thing and put some mins and maxes on there. So the procedure for that was simply making a new M file, and we want to call it by this name, so we got to make the M file's name the same. So that's why we call this myfunc.m, because we're calling myfunc from this file. Over here, this is what we call the output, or the return value, and this is our function declaration. So it's always function output equals name and then the parameters. And we need to define those parameters before we send them to the function. So in other words, if I take this 0.5 and I put it after the point where we send it to the function, we're going to get an error message because it tried to send A, but A was not yet declared. So be careful about that. Make sure these parameters are defined before you call them in the function. So when it gets here, our output is a function with a function handle. Over here, we don't need to use this handle because it looks at y and it sees this line here. Over here, we need to use the function handle because we've altered the function, so we need to redefine the function with this function handle. Because remember, it's flipped upside down. And get these. The plotting part you should already know, so I'm not going to go into a lot of detail of that. Okay, so again, I'm going to make a new cell for the next exercise, and see we have these variables up here. So I want to clear these, and I want to clear the command line, so I don't see a bunch of garbage every time we get an error message. I'll just go turn that off right there. Okay, so the next project is pretty hard. It starts off okay, but we'll see in part C it's a complete mess. So the idea is that Sophocles will give you some sort of file, in this case rec0506.dat, and that is just this, I guess, Excel spreadsheet or array, or matrix even, here. And he wants you to read that file and be able to get certain information from it. And you basically need a set of functions that I'm going to go over briefly now. So the first thing you need to do is you need to open the file that he wants you to actually use. And again, that's rec0506.net. Okay, so the first error you'll definitely get is this one. It's going to be doesn't recognize what this file is, and that has usually two problems. One problem is that this dat file needs to be found in the same workspace or library that your recitation file is in. If it's not in the same workspace, it's not going to be able to access it. So you need to make sure that's done correctly. The second error, and the one that took me a while when I was first doing it, is that you need to put this in quotes because it's a string. And the number you'll get in as output doesn't actually mean anything to you, but it's what the computer assigns to the file as an ID. So we're going to call that the FID. So that's pretty much how the computer finds what that file is. It just assigns it an ID, and we're going to use that for some of the functions later on. So this one, well, actually let's check out the data file. You've already seen it before in the worksheet, but it pretty much looks exactly like he told you. So we want to skip this row, and we want to skip this row. The way we do that is by getting the line, and when you use fgetl, you need to input the file ID, which is what we got from the fopen. So if you put in the file ID, what you get is the first line. Alright, cool, but we want to skip that line, so we'll keep going. We'll do that twice. So we'll get this row, and now finally we're at this point, which is the data that we actually want. So what does he want us to do with this data? He wants us to skip the two header lines using fgetl. We already did that, and we want to use fscanf to get the three numerical columns into a 4x3 matrix. Okay. So whenever he gives you a function that you're not entirely sure how to use, you either want to go into his PowerPoints and figure out how to use it, or easier, you can just use the documentation in Matlab and try to figure out what's going on. So what fscanf seems to do is it takes an ID, a format type, and a size, and it uses that to get you, I guess, the array or matrix you want. So in this case, what that means is first we need to put in the ID. That's fairly straightforward. Format is what usually confuses people. So in computer science, there's these, I guess, their name escapes me at the point, but basically these characters that have percent signs in front of them, and they're basically stand-ins for reading certain data types from the computer. So %s would be reading a string from the computer, %f would be typically reading a, well, I guess a number from the computer. So since we want 3 columns, we're going to have %f for this, %f for this, and %f for this. But we want to skip over these 2 columns because they're not numbers, they're strings. Anything that has characters in it is considered a string. So the procedure for that is, first column we want a number, so we're going to have the %f. Second column we want to skip, so we put a $s. That stands for skip string, I guess. We're going to do that twice. And then we want another column of numbers and another column of numbers. And the shape that we eventually want, if you'll remember from our, I guess, the recitation worksheet, is a 4x3. So that is what this gets us. So again, we just pulled 3 columns of numbers. So we got a %f for numbers here, skipped over a string, got another column of numbers and another column of numbers. That's essentially all we did here. And I believe that's essentially all you wanted. Extract and display individual columns, X, Y, and Z. Okay, well that isn't difficult to do, so if we name this output A, all we need to do to get each of those columns is this, sorry, I didn't get the equal sign. So this is just basically manipulating matrices. You should have learned how to do this in the first 2 weeks. So this is just grabbing each column that we made, what am I doing, from A, and A is just the output of that file reading. Okay, so there should be second column numbers. Oh, well, I didn't change these. So now it should be the second column numbers and the third column numbers. Alright, cool. So the next thing we need to figure out how to do is, well, actually, we want to grab the columns of strings. Okay, so this is where things get a little bit complicated. So strings are pretty complex. Unlike numbers, which you manipulate using matrices and vectors, strings, you need something called a cell. A cell is pretty much a beefed up kind of matrix that can hold strings in it. And strings are complicated because, well, for a lot of reasons. They're actually technically vectors or matrices of characters. So basically you need a different data type for it. And if that doesn't make any sense to you, you could pretty much ignore that and pretend I didn't say that. But what comes down to is you can't really use this fscanf. What you want to use is something called a text scan. And the text scan, again, all you have to do is really read the documentation, is the same idea. So you take, well, let me check it, I have to rewind. Okay, yeah, we do have to rewind. So the way you rewind is basically just going back to the top of this file that we're reading from. So again, we're reading from rec0506.dat. We're currently here, but we've performed too many operations on this file, so we need to go back to the beginning. So what you need to do is something called an frewind using the FID, and that brings us back to the start, so that when we get the lines again, we're back at the beginning of the file. So you skip the first two lines again, and now we want to read the text characters instead of the numerical characters. Sorry, I meant characters as in, like, okay, not character as in like computer science lingo, like, okay, numbers, we got the numbers, we want to get the letters now. Let's try not to overcomplicate things. So basically we do the same thing here where we take the ID, and then we need this format string once again. Except this time we want the strings and we don't want numbers. So we do that. And what you get is, again, what I was talking about was these cells. And the cells are basically data structures that can hold matrices and vectors. So whenever you're using cells, you must use curly braces, not parentheses. So they behave similarly to matrices or vectors in the way you access them. And here, S1 is accessing the first column of this cell, which is actually a cell in itself, this 4x1. So it's displaying this 4x1. And here, that displays the other cell, which is essentially, in this case, a vector that's of string characters. Okay, so that accomplishes that. Okay, so this is where things get very, very difficult. So part C is the, probably, if not the worst problem that you will deal with in this entire course, is certainly up there. It's very innocent appearing, but it's a complete mess. If you need a reason to go to college, I mean, like, or self-medicate, like, this is it. So basically the idea here is that you want to, instead of read a file, you want to write to a file. And what you want to do is you want to write this rec0506.dat, but you want to change it so that everything is sorted by this column. So notice here how y has no ordering in this column, but over here it's arranged so that the values here ascend. And in ascension order, it would be first spot, fourth spot, second, and then third. So here it rearranges the other columns in regards to that order. So here, first spot, fourth spot, third spot, second spot, and that is reflected here. So you have first spot, fourth spot, third spot, second spot. So that's a little complicated, but we'll try to, I guess, make sense of everything. Okay, so what we're eventually going to need to use to write to that file is something called fprintf. Fprintf is one of those guys that you're going to have to know very well, because he starts coming up all over the place. He's a pretty important guy. But before we get to that, we want all of the data here, numbers and strings included, because we're eventually going to need to write that to the file. So how are we going to get that? Well, that part isn't too bad. We're just going to use the text scan. So text scan works for strings. It could also work for, I guess, numbers. Scanf, pretty much want to stick to numbers, but it could probably also do strings. They're pretty much functions that work the same. Don't get too worked up about it, is kind of what I'm saying here. So we want to get all the data. What that's going to look like is, whoops, sort of like this. So that's all of this here. But the problem is we have cells. So whenever you have strings, you're going to get cells. And these cells make things rather difficult to deal with. So the first thing I'm going to do is I'm going to pretty much take each of these columns and put them into things I could easily work with. So in the case of numbers, I'm going to take this 4x1 double and I'm just going to put it into a vector. So we're going to extract vectors from some of these, and some of these we're still going to get cells. In this case, F2 still going to be a cell because there are strings. We're going to do this a few more times. So again, whenever you're dealing with strings, whenever you're dealing with cells, you're going to need to use those curly braces. Don't use parentheses. Things will go horribly wrong if you use parentheses here. Matrices vectors, you'll use parentheses. On cells, you'll be using these curly braces. So now everything has been successfully put into, I guess, these vectors or these cells. So the other thing I wanted to talk about was using fprintf. So this whole format string idea is something that you use in fprintf that you've probably used before. So if I wanted just to display those numerical columns using a vectorized fprintf statement, I would simply put the numerical vectors, that's the first, fourth, and fifth columns, into this matrix and display them like that. And of course you can't forget the new line carriage. So that looks like this. Another thing, if you haven't noticed with fprintf, is that you could put these numbers before fprintf, or before the percents, after the percents, but in these percent characters, and that controls the output down here. So I put 8.3. Why did I put 8.3? Well, 3 tells you the number of decimal places, so in that case each of these is going to have 3 decimal places. I chose that because I have this number over here, and 8 is the number of spaces that each of these get. So I could either pack them really closely together, or, well, you're not seeing it because I'm only changing one at a time. See, that moves those over in the second column because I'm altering the second set of numbers. So I could either pack these numbers really close together, or I could spread them out using the first number here. Second number, decimal points, first number, spaces. Okay? So that's printing the numbers. So, thing is, fprintf doesn't cooperate very well with cells. It just doesn't do them. So if I wanted to print just the strings here, I would do this, or you think I'd do this, but the unfortunate reality is you can't. Fprintf isn't defined for cells, which makes this problem a lot more complicated. So instead what you need to do is use something that you'll be introduced to later called a for loop. So a for loop is basically a structure that executes something a certain number of times. So in this case, when I is 1 to 4, it'll do whatever is inside this loop. So that means when I is 1, it'll do something, then I will increase to 2. And then this statement will execute again, and it'll do that for when I is 1, 2, 3, and 4. So it basically gives you a way of doing the same process over and over again. And in this case, we want to apply that to printing a statement. So instead of using this vector over here, what we're going to do is we're going to apply that to our vectors separately. So we'll get the same output as we do with the vectorized fprintf. So that's how you do it with the numbers. Let's do it with the cells. So again, I'll take this and we'll put it here. So then we're going to have that %s, should be lowercase, and another %s. Alright, cool. And here, where we had that C2 and we had that C3, those are columns that have strings in them. We're going to use the braces like this, and that's going to access each element of that string and print it out just like it did with the numbers. So if we want to print out everything at the same time using just one fprintf that's in the for loop, simply all we need to do is kind of mash them together. So put the s's here, put C2 here, and remember C2 is a cell, so we're going to need braces here, and that should work. Might be too optimistic, but okay. So we probably want to make that a bit nicer. Okay, that was silly. I'm just going to put 8s here. Just to spread everyone out so we can kind of tell what's going on. Okay, that's nice enough. So there we have most of the things we want displayed. But keep in mind we haven't yet organized them in regards to this column, and that's kind of difficult in and of itself. So how do we do that? Well, there's this function called sort, and what sort does is, in the documentation over here, it will actually return, well, okay, here you could set something to ascend. So what we're going to do is we're going to set that third column to ascend, and over here, with this I over here, that'll actually display the indices that were used to put this into ascending order. So that's what we're going to do right now. And again, that's the fourth column here, so I'm going to take C4. I'm going to put it here, and we're going to put it in ascend. So that organizes the column, and now we're going to take the index that we wanted. So again, as we were talking before, that's 1, 4, 3, 2. Okay, so that's where this gets, again, even more complicated. So I'm actually going to call this J. So if I want to sort everything by 1, 4, 3, 2, what I can do is change this so that it's applied to each part of J. So think about that for a little bit. It's a little complicated, but this will change it so that this is displayed by the index there, and that's what you see here. So that's how we account for that. The last difficulty, well, there are two other things that it wanted to do. They wanted us to fprintf the getLs for this, but that's pretty simple to do. So I'll just kind of throw them in here. Fprintf that. Actually, I'll store those because I believe we rewinded, so it's just a lot safer to just store these as L1 and L2. So I'll call that L1. Call this L2. And I spelled fprintf wrong. Okay, and the other thing we're going to want is we're going to want to put in that return character, just like that. Let me just copy this. So, there. Okay, so the last thing we want to do is we want to actually write this to a file. And the way we do that is we have fopen, we give the new file name, sorry, I'm completely messing that up, we'll call that, I don't know, kittens.that, and we specify we want to write, and just like before when we had the fopen, we need to specify an ID for that. So this is when things get a bit complicated, and again we want to write it after we have all the stuff from our previous file. So here we rewind, here we get that. I'm going to close the the rec 0506.dat. Then here I'm going to open it, write this information, close it. Here in the fprintf, we need to write that to the file. Same thing here. Close it, and then if we use this, we should be able to see it. So there, that's that. And over here, we can see that it's been created, and it has exactly what we want. So I know I kind of blathered on for a bit, probably some unnecessary details here, but I hope that helped you get some sort of grasp on what is happening in this week in Matlab, because this is when the course starts getting pretty difficult. So